Hello, and welcome to this lesson on interpreting stem and leaf plots and histograms. These two things kind of go together because they're both measures of dispersion, and we'll talk about that in a little bit. How do I interpret stem and leaf plots and histograms is the essential question. So a stem and leaf plot is used to show the dispersion of a data. That word, dispersion, it means where the data is chunked or spaced out, where there's large groups of it, where there's not much data. There are other graphs like the histogram, we'll talk about in this lesson, and the box and whisker plot, we'll talk about in the next lesson, that kind of do the same job. The difference is like the box and whisker plot is a summary of the data, where the stem and leaf plot contains the entire set of data. So that's useful like if you have a small amount of data and you want to see the actual data points. Stem and leaf plot does a good job at that. If you have a million pieces of data, well then something like a histogram or a box and whisker plot will do a much better job of showing the dispersion because it's very impractical to show a million points of data in a stem and leaf plot. So stem and leaf plot, it's a data display that organizes numbers based on their digits. The frequency is just how often a number occurs. That's what frequency means, how often something happens. And then these bottom two, I kind of put a line here because these bottom two very much go together. A frequency table is used to group data into equal intervals. And then a histogram is a data display. Data display is used to show the frequency of data values, and this is really just a graph of this frequency table. So in this lesson, we're going to have three problems twice. We're going to do these three problems, and first we're going to make a stem and leaf plot from the data. Then we're going to do a little bit of practice, and then we're going to make histograms of the same sets of data. Okay. So number of home runs hit by 20 baseball players with the single best season batting averages in Major League Baseball since 1900 are listed below. Make a stem and leaf plot of the data. Now, this is pretty low, so these are maybe since before 1900, I don't know. So we want to make a stem and leaf plot of the data. So here's how this works. First thing you got to do is you got to find your biggest number and your smallest number. My smallest number appears to be 3, and my largest number appears to be 42. Right there. Oops. Now, a stem and leaf plot, you always need 2 digits. 2. I lied. Sometimes there's 3. But in this case, the stem and leaf plot, basically, we're going to chop the tens digit apart from the ones digit. And each of these numbers we're going to chop. But with a single digit number like this, chop, what would be your number out front here? Well, it'd be a 0. The number 3 is the same as the number 03. See? Calculate, understand. 03 is just 3. So we're going to put our smallest stem, the first number is called the stem, at the top of the stem and leaf, and our largest stem at the bottom. And fill in every number in between. Between 0 and 4, we need every single number. 1, 2, 3. Even if they wouldn't be used, we still need them. Now, we're going to go through and we're going to put, the leaf piece, that's the second number, for each of these numbers in their appropriate location over here. Now, there's 2 different ways of making a stem and leaf plot. There's just the regular stem and leaf plot, and then there's the ordered. I'll show you both. So the regular stem and leaf plot would look kind of like this. I would just go through the numbers, 14. So here's my 1, and here's the 4. So this means 14. 25, 2, 5, 8. That'd be a 0, 8, 0, 8. 0, 7, 0, 7, 1, 9, 3, 7, 3, 9, 1, 8, 4, 2, 2, 3, 0, 4, 3, 2, 1, 4, 2, 1, 0, 3, 1, 2, 1, 9, 4, 1. So there is a stem and leaf plot almost. We have to do one more quick thing before we're done with that stem and leaf plot, and that is to make a key. The key tells us how to interpret this stem and leaf plot. So all I really do is I pick a value. Actually, I like to pick this bottom one, so I'd say like 4/2, and tell us what it means. That's the number 42. So that is a finished stem and leaf plot. Now we can see the dispersion, the chunking of the data. I can see there's lots of people who got in the single digit and teens as far as home runs. Not many people got in the 20s, 30s, and 40s. That's what a stem and leaf plot is there for. It's showing where there's lots of data and where there's little data, where the data is spread out and chunked together. This is a regular stem and leaf plot, although I'll be honest, I don't really like that one. I like what's called the ordered stem and leaf plot. The difference is, in the ordered stem and leaf plot, these values, these leaf values, are put in order. There's something wrong here. There should not be a 0 right there. 7, that was supposed to be a 4. So these numbers in order would go 3, 4, 7, 7, 8, 8. I just looked at this list and I put them in order. Looking at this list, I'm going to put them in order. So it would be 2, 4, 4, 8, 9, 9. 1, 3, 5. 2, 7, 9. 1, 2. There. That's called an ordered stem and leaf plot. This side is your stem, this side is your leaf, and you'd still need a key to go along with. I'm just going to leave this key for both of them. From this stem and leaf plot, we could find things like the mean, the median, the mode. The mode is, well, we've got actually a bunch of them. We have a mode of 7, 8, 14, and 19. 7, there's 2 7s, there's 2 8s, there's 2 14s, there's 2 19s. And that's how you'd read this. This is the number 1, 9, 19. This is the number 39, 23, 7. Okay? So we can find things like the mode. We could find things like the mean. I could add up 3 plus 4 plus 7 plus 7 plus 8 plus 8 plus 12, 14, 14, 18, 19, 19, and all of them, and then divide. And finding the median, I can find the middle number. Although, I'll be honest, I find the mean and mode and stuff from this to be a little confusing. I like the set of numbers better. So a lot of times if they gave me a set of a stem and leaf plot and said, find the median, I might just take this and write out the numbers, write out what this means in numbers, and then find the median or the mean or whatever it is I'm doing. Okay, make a stem and leaf plot from the data. Find your smallest number, find your largest number, and so just like before, we're going to chop off that last digit. That last digit is going to be your leaf. So the stem part is going to be 0 to 4. 1, 2, 3. You get all your values in between, just like we did before. Now I'm going to be a little bit more strategic in making my stem and leaf plot this time, because I like them in order. So what I'm going to do is I'm going to try to find all my 0 point things, and I'm going to put them in order first, which he's actually the only one. And then I'm going to look for all my 1 points. So anything that would go in this next stem. So I've got a 1.9, 1.9, 1.6, 1.2. So in order, 2, 6, 9, 9. The last digit is your leaf, the last digit is your leaf, and there, and there. So 2, 6, 9, 9. And then I'd look for all my 20s. I see one of them. He's the only 20 I see, 23, or 2.3, I'm sorry. So 2.3. And then I look for my 30s, or 3.0s, 3 point somethings, and there are none. Now, we don't do this. That would be wrong. That would be bad. That tells somebody that there's a number 3.0 somewhere up here, and there's not. Okay? So we don't put that. We just leave it blank. Now people know there's nothing in this 3 column, the 3 point anythings. Then I do the 4 points. I see a 5, a 7, a 5, and a 2. So in order, 2, 5, 5, 7. So if you're good, you can make an ordered stem and leaf plot right from the get-go. You don't have to make one first and then rearrange them. Key is required. 4/2. Now this doesn't equal 42, it's 4.2. That's how we would interpret it. And now we can see the dispersion of the data. We can see that there's lots of 4 point things and 1 point things. We can see there's no anything that's a 3.0 or 3 point anything. That's the dispersion. That's where there's big chunks and where there's little chunks, where it's spaced out and where it's pushed together. The test scores in a small math class were blah, 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 blah. Make a stem and leaf plot of the data. Which letter grade occurred the most? Okay, so we have from 50 something up to 90 something. So 5, 6, 7, 8, 9 is my stem. So 50s, 60s, 70s, 80s, and 90s. Ooh, I lied. I missed it. There's a 45 up there. So 40. Make my stem a little bigger. So there's a 45, a 56. There are no 60s. There is 170, 80, 83, 87, 80, 83, 87, and 2 of these. And you make your key. 9/2 equals 92. So there's our stem and leaf plot that would go along with this data. Which letter grade occurred the most? Well, based off our data, we can see that the B's, the 80s, occurred the most. So that's making a stem and leaf plot. All right. Here is one for you to try on your own. Now this has a bunch of data. Now I will help you out here a little bit. So your stem, remember the leaf is always the last digit. So the stem would be, in this case, those first 3. So you have, that's a stem of 181. That's a stem of 180. And then the leaf would be just this last digit here and that last digit there. Okay, so go ahead and as you're making your stem, I'll get you started because this is a new type of thing. Like that. That's how you would start your stem. Go ahead and pause the video and make that stem and leaf plot for number 1 and then answer the question in number 2, please. Okay, so I think that's all you need for your stem. Now this is going to be a little bit harder to do in order right off the bat. So I'm going to just make it and then we'll see about if I want to put it in order. So 178, 177, and there's another 8 and a 6, 1792, 1812. I've done up to there. 1788, 1788, 1817, 1888, 1787, 1788, 1789, 1803, 1787, 1790, 1788, 1796, 1791, 1788. So make a 7-leaf plot. The only thing I'm missing from an actual thing is my key. So 181/6 would be 1816. There. You know what? I'm not even going to put it in order. I don't need it in order. It's just, I like it. That's prettiness for me, but I don't think it's required. So in example 1, describe the distribution of the data on the intervals represented by the stems. Are the data clustered together in any noticeable way? Well, heck yeah. You should have said that after making this, there's a lot of data, a lot of the first 20 states were admitted into the Union in the 1780s. That's where there's the largest chunk in the 1780s. And then after that, there's not as much. So something like most of the data is in the 1780s. I don't think I need the apostrophe. There we go. So most of the data is in the 1780s. That's where most of the states joined the Union. We can see only one state joined in the 1800 years, 1803. But most joined right away. And in fact, the one that happens the most is 1788. Okay, so that was all stem and leaf plots. Let's talk about histograms. Histograms are quite similar. Their job is to do kind of the same thing, except it's more of a summary of the data. We're not going to have each individual piece. Like up here, there we go. This is the same problem we did as a stem and leaf plot. Okay, you see how we have every single piece of the data. Each one of these has its place. Well, in our histogram, we're not going to have every single number. So the first thing we need to do is, like before, figure out our smallest and largest numbers. And in a histogram, we like between 3 and 5 categories. So what I like to do is I like to take these guys. Okay, 42 minus 3. The range is about 39. Does that divide by 3, 4, or 5 evenly? Or even a number close to that? Well, if we imagine that's 40, 40 divided by 4 works well. 40 divided by 5 works well. 39 technically can divide exactly by 3. So we could use 3, 4, or 5. This is a decision you have to make. I'm going to choose 4. So I'm going to have 4 categories here. And now the hardest part is making each interval the exact same size. Okay, so if I'm going to go up to here, so I'm going to start at, say, 3? Or should we start at 0? Decisions, problem solving. Okay. So let's say we went from 0 up to, say, I'll just do it this way. I was going to do it. I'm going to go, and I'm going to make each interval 10 big. So 0 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 10 units big. Because 0 counts as one of those numbers that could be in there. There could be 10 numbers in this interval. Oops, why did I start it from 0? That was wrong. I meant to start from 3. From 3 up to 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I am using my fingers, by the way. I don't know if you can hear me counting using my fingers to make sure there's 10 numbers in here. 3 is one of your numbers. So 3 is 1. 4, 5, 6, 7, 8, 9, 10, 11, 12. That gives me 10 fingers up right now. Your next interval needs to start at the next number. You're not allowed to have any gaps. If this one stops at 12, the next one has to start at 13. You can't start at like 15 or 20. You have to you have to go to the very next number. And then I'm going to do the same thing. From 13, 10 numbers up would be 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. And I'm starting to see a pattern here. From 23 up to 32. From 33 up to 42. I can see the pattern that I was building here. And that does cover every single number in my intervals, my data here. Now, from here, I'm going to make a quick little tally chart. I'm just going to quickly record which interval each of these numbers falls in. So 14 falls in there. 25 falls in there. 8, 8, 7, 7, 19, 37, 39, 18, 42, 23, 4. Remember how you make fence posts? Every little group of fence posts is 5. 32, 14, 21, 3, 12, 19, 41. So there is 7, 6, 3, 4. And then a histogram is just a graph of that. So you have your different intervals down here, 0 to 3 to 12, 13 through 22, 23 through 32, 33 through 42. You have a scale on the side that goes as high as you need to go for your value. So I need to go up to about 7. So 0, 1, 2, 3, 4, 5, 6, 7. And here we go. So now you just make bars, kind of like a bar graph, that are this tall. So my first bar is going to go the whole way up to 7. That was a little high. There we go. My second bar goes up to 6. And you see how these bars, they're a histogram. Usually the bars are wide and they're connected. The next one only goes up to 3. The next one goes up to 4. That is a histogram of this same data. You see how this is more of a summary. It does not have, your graph, your histogram over here, does not have each of these individual pieces of data. It has a graph. Now, if I would compare, looking at this data here and this data here, we see a lot of the same similarities. The first 2 chunks of data have the most. See, they have the most. And then these next couple are quite a bit lower. So it's not the exact same graph, but it is very similar. So that's how you make a histogram. From a set of data, you make intervals. Your intervals must be the exact same size. Your intervals must cover the entire data. You're not allowed any gaps in the intervals. You then just record how many numbers fall in each interval, and then you graph your intervals with some sort of scale that goes as high as you need to go. Okay. Lowest value, highest value. Interval. So I don't know how many intervals I want yet. Somewhere between 3 and 5. So I'm going to figure out the range of this. So 3.8. Does that divide by, well, maybe we can round this. Maybe we can make this like 4, right? We can round that up a little bit. We can round. I wouldn't round down, but you can round up a little bit. So if we divide by 4 categories again, each category would be 1 big, a whole number big. So we can go from 0.9 through 0.9. I'm using my fingers. I'm counting tenths. 0.9, 1.0, 1.1, 1.2, 1.3, 1.4, 1.5, 1.6, 1.7, 1.8. That is 10 tenths. That is 1 whole unit. Now the next one would start at 1.9. Do you see how it's 1 whole number bigger? And then 2.9, and then 3.9. See how it's 1 whole number bigger, 1 whole number bigger, 1 whole number bigger. Fill in your gaps. This one would go up to 2.8, this would go to 3.8, this would go to 4.8. And that covers all of our data. Now we make our tallies to record how many numbers fit in each of these intervals. So 1.9, 4.5, 4.7, 2.3, 1.9, 0.9, 1.6, 4.5, 4.2, and 1.2. That is 3, 3, and 4. So now our histogram would still have, even though there's nothing in here, just like when we did the stem and leaf plot. Let me find it. There it is. The stem and leaf plot had nothing in this 3.0 range. Our histogram is not going to have anything in that range either, which is okay. So let's see. I'm gonna move and shrink stuff a little bit just so I have space. All right. We need 4 categories. 1, 2, 3, 4. That is 0.9 through 1.8, 1.9 through 2.8, 3.9 through 2.9 through 3.8, 3.9 through 4.8. My scale only has to go up to 4 on my y-axis here. So 0, 1, 2, 3, 4. And now my histogram would look like this. Oh, that was terrible. Holy cow. Better, I guess. Boom. Nobody. And then 4. Histogram of the same set of data. It shows dispersion. It shows there's most things happen in this category here where nothing happened in that section of the data there. All right, one for you. This is the test scores. There's 1, 2, 3, 4, 5, 6, 7. There's 8 pieces of data here. So if you could please go ahead and make your frequency table and your histogram of this data right now. Okay, so I've started. I don't know how many categories I want, but I'm gonna make some space. Smallest number is 45, biggest number is 97. So 45 divided by 97 gives me, oopsie, not divide, 45. 97 minus 45. There we go. We got it. It was a range of about 52. Now, maybe if I round this up to 55, I could make 5 categories. I'm trying to think of other numbers here if they're divisible by 3, 4, or 5. Technically, 52 is divisible by 3, I think. No, it's divisible by 4. 52 divided by 4 works. Each category would be 13 big. I'm okay with that. Sure, let's try that. So I go 45. If I add 13, the next category would start at 58. And I add 13. The next category would start at 71. And I add 13. The next category would start at 84. And I don't think I need any more because this should be bigger than the biggest number. Uh-oh. That's exactly the biggest number. That's not good. That's not good because I don't want to have a category that's just 97 and then a few more. That it's only going to have one number in it. So maybe 4 categories wasn't the best. Or I could just make each interval a little bit bigger. Instead of making each interval 13 big, what if I make each of them 14 big? That would fix the problem. So if I do 45 plus 14, 59, plus 14, 73, plus 14 is 87. And if I do it again, now we should be bigger than the biggest number. Okay, so we have 4 intervals. 13 was a little too small. 14 seems to do all right. So now we just fill in the gaps. So this first interval would be from 45 to 58. I'm making it right before this number. 58, 59, 72 to 73, 86 to 87, and then I guess, these would also be going up by 14, right? 72 plus 14 is 86. If I add 14 more, that gives me 100. You might have chosen a different number of intervals. If you chose 3, your intervals will be bigger, but you only have 3 of them as opposed to 4, which is fine. All right, data. 97, 83, 45, 87, 80, 92, 78, 56. So we have 2, 3, and 3. Our histogram. Let's see. 45 through 58. 59 through 72. 73 through 86. 87 through 100. And 0, 1, 2, 3. We have 2 for the first interval, 0 for the second, 3 for the third and fourth intervals. And we can see how similar this may look to our stem and leaf plot. Here is the stem and leaf plot. We had 6 categories. 1, 2, 3, 4, 5. We have 6 categories here. And you can see we have low amounts of data on the low end, higher amounts of data on the high end. Well, as our histogram, low amounts of data on the low end, high amounts of data on the high end with nobody in the middle. Okay, so that is our histogram. These are the last 2 problems of this lesson. If you could, please. This one, you do not have to make a stem and leaf plot. Read the directions. It's going to have you compare. And this one's going to have you make a histogram. So go ahead and pause the video and do these last 2 problems right now. When you're ready to continue, hit play, and we will go through them together. All right. The back-to-back stem and leaf plot shows the percents of students in 24 countries who report watching television for 4 or more hours each day. Compare the data for female and male students. Okay, so what would we say? Well, we'd say that based off this data, females tend to watch less TV than the males. Like 14% watch 4 more a day in that country, 15% watch in that country, 19% in that country, where the males, we can see the groupings are more on the this lower end, so more are watching TV than the females. Boom. Females tend to watch less TV than the males according to this data. And that's just comparing. That's saying how they're similar and how they're different. This last one here is making a histogram. So we need our frequency table with our intervals. Interval. I don't know how many intervals I want. I should really make those bigger. Like that. All right, so let's see. Smallest number is 10. Largest number is 20. That's a range of 10. From 20 minus 10 is a range of 10. How many intervals do we want? I mean, we could do 4. It's a little weird. We could do 3. We could do 5. I don't know if we'd want to do 5 intervals. We could. Now, the problem with doing 5, I think that we're going to come up with is each interval is going to be 2, right? If we did, zooming in here, if we did 10 plus 2 is 12 plus 2 is 14, 16 is 18. Again, we have that situation where we've chopped off our largest number. Our largest number of 20 would be in its own separate category. So instead of making each category 2 units big, if we make each category 3 units big, I think that'll work out in our favor. 13, oopsie, what am I doing? 17, 20? I don't know. That's a lose-lose situation because, again, he's the only number in that category, but whatever. I mean, I guess we have to do something. There may not be a good way to have all of this data in the categories. I mean, you could always try and say, well, what happens if I did, like, 4 in each category? 10 to 14 to 18 to 22, which means this category wouldn't be used. That only gives us 3 intervals, which is okay. So it'll be 10 to 13, 14 to 17, 18 to 21. You know, I rather like that. I like it better because I don't like a number being the only one in his own category. I don't really like that. So I think what I would do is I would do this. Now, if you chose something different, if you did the 4 categories or the 5 categories, I'm not saying you're wrong. I'm just giving you a personal preference on what I like. Now, I would take each of those and tally. 20, 17, 16, 14, 13, 11, 10, 10, 11, 12, 16, and 19. There we go. And now my histogram, if I can make my marker a little bigger again. By the way, this is 6, 4, and 2. I only have 3 categories, so I can make them a little bigger. 10 through 13, 14 through 17, 18 through 21. 0, 2, 4, 6. And this actually works out because each of these was multiples of 2. So we got 6 for the first one, 4 for the second one, and 2 for the last one. Boom. There's my histogram. Intervals have to be the same size. You can't have any overlapping numbers or skipped numbers. And it's good to have somewhere between 3 and 5. And you saw it does take some guessing and checking before you can get a good one that seems to work out well. So summary, how do I display data in a stem and leaf plot and a histogram? Just think about it, put down some words on summarizing what you do. Okay, so for a stem and leaf plot, you find your largest and smallest numbers. You then fill in the stem part, being the front digits. Everything except for the last digit goes in your stem. You then pick the stem, the last digit of each of these numbers, and it goes next to the stem in the leaf category. So stem, leaf. So that would be 1/4. He's right here. 2/5. He's right here. As far as StemandLeaf plots, you have both the regular and the ordered. Ordered is where your leaves are put in numerical order. As far as a histogram of the same set of data, you start by, again, finding your biggest and smallest. Calculate the range. You want your intervals to have the same number of numbers in each interval. They have to be the exact same size. You can't have any overlap, and you can't have any skipped numbers. And that's sometimes how they might try to trick you, is they'll have intervals and say, well, what's wrong with this histogram? And they might have like a 22 here and a 22 there. Well, you can't have that. You can't repeat a number. So if you'd have the number 22 up here, would you go in this category or that one? And then you make a tallies, and you're just recording how many of these data values fit in each of the intervals. And then you graph that in something that looks similar to a bar graph. But this is called a histogram. And that's it. Okay. These are both measures of dispersion. You can see how they show where the data is chunked together and where it is spaced out. We have one more type to look at called a box and whisker plot, and that is the next lesson. Thank you so much for watching, and until next time, toodles.